All right, so we're on to our second video. So you should have already watched the first video. Remind you, the first video is on the scientific method, right? You should have learned all about that in the previous one. So in this one, we're going to move on to elements, compounds, and mixtures. And actually, this relates to what we just talked about in the first one, right? In the first one, we said chemistry is the study of matter and the changes that it undergoes, right? Matter, what was matter again? Anything around us, really, right? So chemists study matter. Now in this video, we're going to learn that matter, everything around us, matter can be divided into three categories. Those three categories are elements, compounds, and mixtures. So we're going to learn about what the differences are, like kind of how to understand what the differences are. And maybe more importantly, really what I want you to be able to do is if I tell you something, like if I tell you, I don't know, plastic or alcohol or I don't know what else, salt water, I want you to be able to tell me what category items are in. Are they elements, compounds, and mixtures? All right, so with that, let's go ahead and get started with elements. So let me flip to the next slide here. Oop, there we go. And for an element, well, first off, let me tell you kind of the book definition of an element. An element is a substance that is composed of only one kind of atom. A substance that's composed of only one kind of atom. All right. How do you know if you have an element? What's a more practical definition? Well, a more practical definition is that you'll see them listed on the periodic table. Listed on the periodic table. If something is on the periodic table, that something is an element. All right, so along with it in this module, there should be a link to a periodic table. I'd highly recommend you download it and print it, maybe print a few copies because we're going to end up writing all over it and doing all kinds of taking notes on it eventually and so on. So having that periodic table handy is really important. Periodic table and chemists, oh, we love each other. We love that periodic table. I love my periodic table almost as much as my kids. All right, maybe not quite that much, but I do use it a lot. I spend a whole lot of time with the periodic table. So let's go ahead and look at it. So let me flip over here. All right, so the periodic table looks just something like this. Lists all the elements. Now, there's all these numbers. You'll see, well, eventually we'll get to what all these numbers mean. That'll be coming up in a future chapter. But for today, let's just talk about what these elements are. Now, I said usually you're going to need to know what these elements are, and usually you might think, well, I need to know the name of them, and that's true, but on this periodic table, I don't really give you the name of them, right? I give you the shorthand, the symbol. So usually on the periodic table, you'll just see the symbol of the element. Some of these are things, again, you maybe have heard of, like in that last video, I talked about copper, right? Copper, it's in your electrical wiring in your house. Copper is an element. Do you have any idea what the symbol is for copper? Copper's right here. It's Cu. Copper's an element. What are some other elements you might have heard of? Oh, what's the part of air right now you're breathing that you really need? What's the part of air that's super important to you? Oxygen. Oxygen is an element. What are some other ones? Oh, what's the sun mostly made out of? It's made out of hydrogen is mostly what the sun is made out of. Or what do they make, I don't know, really expensive bicycles out of? Oh, titanium. Titanium is an element. All right, so some of them you might have heard of. We're going to eventually go through and learn them, like the symbols. You're going to need to know like 30 or 40 of them, be really familiar with, because we'll use them a lot. When we get most of those common elements that we're going to focus in on, they're towards the top of the periodic table. The ones down towards the bottom are not nearly as common, so we won't spend as much time on them. Often the ones towards the bottom, they're kind of the more recently made elements. Actually, the ones towards the bottom are all made by humans, and when they make them, they name them. They might name them after a famous person, like there's an element named after Einstein, Einsteinium. There's one named after the guy who came up with the Nobel Prize, Beryllium. There's sometimes, besides naming them after famous people, they might name them after like places where they were discovered or created. Like for example, there's one named after California, Californium, right down here, 98, Californium. And actually, for the longest time, I would always tell people we're the only state with an element named after us. Lucky us, we have our own element in California. But a few years ago, they named another element after a different state, a state where they actually do a lot of work making these elements. 117, this is actually a little old periodic table. They changed it recently. 117 is now named after Tennessee. It's Tennesseeum or something like that. So there's actually two states. It's actually its new symbol is TN. They changed it. There's actually two states named with elements named after them. All right, so with that, again, the ones towards the bottom, these wacky ones, Californium and Einsteinium, we're not going to spend a whole lot of time talking about those. We're mainly going to focus in on the top part of the periodic table because that's where the ones that we find around us a lot more commonly that's where they are on the periodic table. All right, so with that, let me flip to another slide, and you really are going to need to get familiar with these symbols. So let's go over a few of them today. So let me move on to another slide and we'll do that. Okay, so let me go over, usually I like to do like 10 a week, right? So we want to learn maybe 10 a week. By the end of the semester, you're going to be super familiar with maybe 40 or 50 of them, all right? So let me make a little list of the ones that you need to know, right, off the top of your head. If you don't know them off the top of your head and you got to keep looking them up, it's going to take you forever to get through the homework and stuff, all right? So number 1 is H. Number 2, I'm just going across the periodic table here. Number 2 is He. Number 3 is Li. We're going to keep going all the way. We're going to do the first 10. That means really we're doing the first 4 rows. First 2 rows, I should say. Number 4 is Be. Number 5, right there, B. Number 6 is C. Number 7 is N. Number 8 is O. Number 9 is F. And number 10 is NE. All right. What do all those letters stand for? All right. Well, let's go through the list here. So H, you may know what H is. H is hydrogen. H is hydrogen. I just told you it's a major part of the sun. The other part of the sun is He. He is the second most common element in the sun. It's helium. Helium. That's an H there in the beginning. Oh, that's an H. All right, Li. Li is a lithium. It's used sometimes as a medication for people who have a bipolar disorder. Be. Be, not a super common element. It's out there though. Be stands for beryllium. Beryllium. B is actually one that they mine a lot in California. It's found a lot out in the desert in the middle of nowhere. B stands for boron. There's even a town in California named Boron after that element. It's not a super exciting town, I don't think, but it's out there in the middle of the desert, Boron, California. All right, now the remaining ones again are ones maybe you've heard a little bit more about. C, see my C? C is carbon. N is nitrogen. O, do you know what O is? O is oxygen. Oh, I think I mentioned that one a little while ago, actually. F is fluorine. And Ne is neon. All right, so with that, you should be familiar with these symbols. You'll need to kind of be really familiar with them because we're going to use them all the time. So if you haven't written them down, I'd write them down. You know, you can make some flashcards if you need to help you remember what these are so you don't have to look them up all the time. All right, with that, element. Element, if you're on the periodic table, you're an element. Anything listed on the periodic table is an element. All right, so let's move on to compounds. I got to move on to the next slide to do that. So compounds are elements put together, basically. Well, let's be a little more specific, though. They are 2 or more elements chemically joined together Two or more elements chemically joined together. And we'll say in the same ratio. Chemically joined together in the same ratio. All right, so let me explain a little bit more about what that means. So first off, what do I mean by the same ratio? Well, the way that we know that they're joined together in the same ratio is that for a compound, you're going to see written down, either I'll tell you, or you can look it up, or you can make up on your own, I suppose. You're going to see a formula, see a chemical formula. If you can write a formula for something, that something is a compound. The formula is basically telling you the ratio of atoms, the ratio of the elements, all right? So for example, probably the most common formula you'll ever run across is the formula for water. Do you know what the formula for water is? What's water? Water has a formula. Water is H2O. H2O. H2O is the formula for water. If I know the formula, if I can look up a formula, I must be thinking about a compound. So what is that telling me, H2O? Well, what that's telling me is water, doesn't matter where you find it, because it's always true, in water, there are two hydrogens with one oxygen. If you don't see a number, it's a 1 there. So after oxygen, there's kind of a hidden 1. H2O. So what we can sometimes do is we build little models. This would be a model of water. So in this model of water, the red guy represents the oxygen on one oxygen, and the white guys are my hydrogens. My white guys are my hydrogens. So there's two hydrogens. So this little model, this is, if we could see a water molecule, that's what it would look like. All right. Now, what are some other compounds? Oh, another one is what I'm exhaling right now. Breathe out, breathe in, breathe out. It's like yoga time. Breathe out. That's carbon dioxide coming out. All right. So CO2 is a compound. The formula for carbon dioxide is CO2. So again, that tells me what's put together. If we could see carbon dioxide, this is what it is. The black guy, that's the carbon. It's been joined up with two red guys. The red guys are the oxygens. So if there's a formula that goes with it, it's a compound. Now, formulas sometimes can be a little bit more complicated. You might see something like this. This is a formula of something that you find in fertilizer. Ammonium phosphate is the name of it. Ammonium phosphate. Okay. So as far as that goes, again, if you grow plants, you might have seen that listed on the bag. So in this formula, this is telling me all the elements that are put together. There's N, nitrogens. There's hydrogens. That's what the H's are. There's a P. P stands for phosphorus. And O is oxygen. So the one tricky thing on this one that you're going to see when we, talk more over the semester is that sometimes we put things in parentheses. So the way this works is if there's a number on the outside of the parentheses, that multiplies times anything on the inside. So in this thing, there would actually be 4 times 3, there would be 12 hydrogens. And then remember again, if there's no number, it's kind of a 1. There would be 3 nitrogens. Now, that 3 only applies to the parentheses. So there's 1 phosphorus. And then, the 4 goes with the oxygen, 4 oxygens. So if you add it all together, this thing's actually pretty big. I didn't want to build it because it would take me forever. It actually is made up of a total of 20 atoms. 20 atoms total. All right. So one last thing I'm going to tell you about a compound. And this is going to be the critical difference from a mixture, which we're going to talk about in a minute. A compound, yeah, you'll see a formula. There'll be a formula that tells you how many of each have joined together. So if you see a formula, that's a compound. They're joined together, always in the same ratio. That's important. When we get to mixtures, you'll see how that's different in a minute. And then the other critical thing is that when we have a compound, compounds are hard to separate. Hard to separate. So keep that in mind. These two facts, same ratio, hard to separate. All right, you'll see that's not true for a mixture. We're going to talk about mixtures on our next slide. So let's go on to it. Okay, so our last category are mixtures. So what the heck is a mixture? So a mixture, well, let me define it again, and then we'll look at some examples. So a mixture is two or more substances that are, and then maybe I'll do this in a different color, not chemically joined together, not chemically joined together, and finally, the other thing that they are not is they are not always in the same ratio, not always in the same ratio. All right, so those two facts are what makes them different than a compound. They are not chemically joined together, and they are not in the same, always in the same ratio. All right, let's go through both of those. All right, so first off, since they are not in the same ratio, what does that mean? What does that mean? They're not in the same ratio. Well, what I mean by that is, where a minute ago I said for a compound, we can write a formula because the ratio is always the same. Water is always H2O. It's always 2 hydrogens and 1 oxygen. That makes it water. Water, if you find it here, you find it on Mars. They found it on Mars. You find it on other planets. You find it on the other side of the world. Water is always H2O. Everywhere. For a mixture, that's not true. Let's say I wanted to make up a mixture. So one way I can make up a mixture is I could mix salt and water together. That would be a mixture. And when you mix salt and water together, your salt water and my salt water may not be identical, right? Like, let's say you had a little sore in your mouth and the doctor says, oh, your dentist says, oh, go home and get out some water. I got some water here, and get out your salt and mix it together. You got to rinse out your mouth because, you know, those sores, man, you want them to go away. And if you, salt water helps your gums heal. So I might go and my doctor says, oh, make up a little salt water, or your doctor says, make up a little salt water, and you go home and you just, you get out your water and you dump in a little salt and you go, okay, a little salt goes in. I'll mix it up. Okay. And you go, oh, that's good. I'm gonna rinse my mouth with that. That's some good salt water. All right, so you make it this way. Now, I do the same thing. You know, I got a little problem. I gotta make up some salt water. So when I go home, you know, I'm not always the smartest person in the world. So I just salt water. What the heck? Oh, I guess more is better. And I dump in a bunch of salt. All right, so my salt water is gonna be, oh my God. Oh yeah, that's looking pretty good now. Oh, my salt water, more is better, right? So I make up my salt water like this. Oh, it's pretty concentrated, huh? So you might make it with a little salt because you're not a crazy person. And I might make it with a lot of salt, but it's still salt water, but not all salt water is identical. So if it's not always the same, that means it's a mixture. It's not always the same. It's different in different places. All right, now, so salt water here and your friend's salt water may not be identical. Now, so if it's inconsistent, it's probably a mixture. Now, the other thing I can tell you about a mixture is that mixtures are not chemically joined together. And there's a thing that makes true. Because they're not chemically joined together, these things, one way that you can tell a mixture is that mixtures are easy. Maybe I'll put it here. It makes it easy to separate. Do you remember a minute ago I said compounds are hard to separate? Mixtures are easy to separate. You can break things apart to separate them in a mixture. Like, for example, let's see here. What do I have? I got a couple things on my desk in front of me. I've got, I brought a mixed, I got a couple things that I want to show you. So first off, um, this is sulfur. Sulfur is actually an element. Now, what I did with this sulfur is I took a little bit of it and I put it in a beaker with this. This is a nail actually, and it wasn't really a nail. I ground it up, or I found it ground up. And you know what a nail is made out of? It's iron. All right, so if I could put the two together in the same beaker, I'm going to show you that in just a minute, actually. So iron and sulfur, and both of them, before I put them in the same beaker, I actually, this yellow stuff is the sulfur. Before I put them together, I kind of pulverized them a little bit, and then this is what I ended up with. This is that beaker with, maybe I'll tip my camera a little bit so you can see it better. There we go. So this is my beaker with my iron and my sulfur mixed together. This is a mixture. Now, one way I know it's a mixture is I can separate it. Like, is there a way to separate iron and sulfur? One way you can do it is you can use a magnet. All right, so I'm going to get a magnet, and this is getting a little hard to show you on the camera. I don't know what I'm doing here. All right, so let me get a magnet, and if I hold it above, what you're going to start to notice is the iron will start coming out. It's sticking to the magnet in my hand, and the sulfur is going to get left behind. So just by swirling the magnet above, now I'm not going to do it long enough to get all of it out, the iron sticks to the magnet and the sulfur doesn't. So I can separate the iron and the sulfur. Now, anytime you have a mixture, you can separate it. So how could you separate salt and water? Well, one way you could do it, oh man, I don't want salt water anymore. I want my salt back. How could you do that? Well, one way you could do it is you could boil it. So if you boil this, this mixture I made up a few minutes ago with salt and water, the water would go up into the air, it would evaporate, and I would have my solid salt. Some of it didn't dissolve, but the rest of it would crystallize back out as well. So if it's separatable, I think that's a word. Is separatable a word? I think it is. If it's separatable, it's a mixture. All right, so with that, let's talk about a couple last little terms here. All right, so mixtures are easy to separate. Mixtures are not always the same everywhere. They're not always in the same ratio. So as far as mixtures go, two last terms you're going to hear. Mixtures, let me put it down here. I think I got room. Mixtures can be either, there's two types of mixtures. They can be homogeneous or they can be heterogeneous. Heterogeneous. All right, so homogeneous is a mixture that is the same throughout, and a heterogeneous mixture is a mixture that is different in different regions. All right, so they're both kinds of mixtures. They're both things you could separate. All right, so let me give an example of each. Let's do a homogeneous mixture. Homogeneous mixture, I raided my kitchen for this part of the lecture here. A homogeneous mixture is like apple juice. It's the same all the way through. Now, it's not all the same thing, right? What's apple juice? It's mostly water, really, but then there's some sugar in there that makes it taste sweet. There's the flavoring that makes the apple taste like apple. There's, I don't know what else is in this thing. There's some sodium. That's not the good part for you. There's other stuff too. Oh, there's a little bit of vitamin C, all kinds of stuff in here. So all those things mixed together makes it a mixture. There would be a way to separate it. I mean, we could evaporate the water, for example, and you would be left with, I guess, some sugar and other stuff, like some residue from it. So you can separate it. That makes it a mixture. But the fact that it's the same, like the top part looks the same as the bottom part, it's consistent, that makes it a homogeneous mixture. Apple juice. Let's see, what else would be another example? Well, kind of a similar example. Gatorade is a homogeneous mixture. It's the same all the way through that bottle of Gatorade. Now, a heterogeneous mixture is a mixture that's different in different regions. So an example of that, again, I told you I rated my refrigerator, is salad dressing. So when you look at salad dressing, do you see how there's like a top layer and a bottom layer? So it's still a bunch of stuff thrown together. It's a mixture. I could separate the stuff, but the stuff didn't even mix. There's a top layer, which is mostly oil, and there's a bottom layer, which is like vinegar and spices and so on. So it has layers, it has regions. So Italian salad dressing, oh, I'm just going to write IDS for Italian salad dressing because I'm running out of room. Another example would be like, oh, an Oreo. That's a delicious example. An Oreo. It's got like layers, right? The chocolate crust layer and that white stuff that's going to give you the heart attack in between, right? The filling. All right, that's a heterogeneous mixture, different in different regions. All right, so with that, let me move on to the final slide. And in the final slide, I want to kind of put all this together. And this is a diagram out of your Tro book. So the book that hopefully you have access to and you can kind of read along to get some more examples. In that book, you're going to see this slide here. All right, so they show you all these categories. Everything in the universe, every single thing in the universe is matter. Matter can be divided up into these categories. Let's start off with the right-hand side. Mixtures. There's two types. Homogeneous, like they use tea. Tea is a mixture, like when you make a cup of tea. Or it could be heterogeneous. Heterogeneous would be like oil and water, two layers or two regions. So they kind of show you what's going on with the molecules in this case. Oh, let me go to this pen. So heterogeneous, there's a molecule that's sitting on top and a different molecule sitting on the bottom. A molecule, I don't know if I mentioned it, it's basically just what we call this unit inside of a compound, like one unit of a compound. All right, now in a homogeneous mixture, everything is kind of mixed together. There's things mixed together. They're all mixed. All right, mixtures, heterogeneous and homogeneous. Now on the other side, we see elements and compounds. Elements, oh, that's the first thing I started with. Only one kind of atom. So the different colors, right, represent different atoms. So this might be the representation of like copper, right, copper atoms. And then a compound is a bunch of atoms stuck together, but always the same way. So this is an example of sugar. Sugar is also a compound. So you can see all of these would be sugar molecules. I guess they show you 3 of them. So compound, always the same atoms, always in the same amount. All right. Now there's one term I didn't mention that's super important, I should have said, which is elements and compounds together are called pure substances. So there's 2 kinds of mixtures, homogeneous, heterogeneous. There's 2 kinds of pure substances, elements and compounds. All right, with that, that's it for our first lecture. When we get together on Zoom, we're going to practice this a little bit, and there'll be some questions in this video. Hopefully you've got them right to help you with this topic too. So if it didn't make sense, on our Zoom sessions, you can ask for some help, or we'll do some more practice on this. So hopefully you're all set for our next class. If not, you can email me, you can call me, I can talk to you more about it, and be glad to help you with any of that stuff. That's my job. That's what I get the big bucks for, to help you guys out. So if you're struggling or mixed up, let me know. Otherwise, I'll see you in our Zoom class.